Okay, so this time we're looking at 2017 number 4b. Time t equals 0, boiled potatoes taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time t equals 0. The internal temperature of the potato is greater than 27 degrees Celsius for all times t greater than 0. The internal temperature of the potato at time t minutes can be modelled by the function h that satisfies the differential equation dh dt equals negative 1/4 of h minus 27, where h of t is measured in degrees Celsius and h of 0 is equal to 91. So part B is the question you asked about. So we'll look at part B. Part A asked about a tangent, but part B is the one we're going to concentrate on here. So in part B, whenever use d2h dt squared, so we're going to have to find the second derivative. Now, normally speaking, that's an easy enough thing to do, but here there is a twist in it. So we know that dh dt, you're told this, is equal to negative 1/4 of h, and I'm just going to multiply this through right now. Negative 1/4 of h plus 27 over 4. Okay, so to get the second derivative, we're going to differentiate again. Okay, which looks like it should be an easy kind of thing to do, but one thing in these questions that they've been asking, or that one twist they've been putting in these questions in recent years, is if we compare this to dy dt, let's say it was, or dy dx rather, okay, dy dx is what we're used to. So if we look at that, then the y and the h are analogous, and the t and the x are analogous. Okay, so the h and the y are in the same place, the t are in matching places, the t and the x are in the matching places. So let's say it was dy dx. This looks like a 2, it's not meant to be, it's just indicating dy. So if it was that way around, we said y and h are the same, so it'd be negative 1/4 y plus 27 over 4. And when you see it like that, you realize then that, oh, this is a y that I'm differentiating here, and that means it's implicit differentiation. So if you were to differentiate this d2y dx squared, okay, so negative 1/4 times y, so it'd be negative 1/4. If it was negative 1/4 x, it would just be negative 1/4. But because it's a y that you're differentiating, you stick on dy dx. Okay, 27 over 4, there's no variable there. 27 over 4 is just constant, so it goes away. So now, applying the same thing over here, that's going to give negative 1/4 h d, and because h is the same as y, you're going to treat it the same way, and you're going to set, instead of dy dx, you're going to say dh dt. Okay, so d2h dt squared is negative 1/4 dh dt. Now what we have to do with that is to determine whether our answer is an underestimate or overestimate. Well, whenever you're trying to say whether a tangent is an underestimate or an overestimate, basically you're thinking about concavity. Okay, so underestimating or overestimating tangents, that depends on the concavity. So let's replace the dh dt now. So this is going to be equal to negative 1/4 on dh dt, but dh dt is up here. Okay, so we're going to fill that in. So it's going to be negative 1/4 on negative 1/4 h plus 27 over 4. That's going to be, what's that going to be? Negative 1, positive actually 1/16 of h minus 27 over 8. Now, what else do you know? You know that internal temperature of the potato is always greater than 27 degrees. Okay, so it's always greater than 27 degrees. I've made a mistake here. This should be 16. Okay, so that means if h, so it's going to be h over 16 minus 27 over 16, which is going to be h minus 27 over 16. So d2h dt squared is h minus 27 over 16. And then again, just to reiterate it, h is always greater than 27. But h is always greater than 27. So that means d2h dt squared. Well, if h is bigger than 27, then h minus 27 will be positive. Okay, so this is always positive. And what that means, okay, is that the graph of h is concave up. If the second derivative is positive, then the graph of h is concave up. Now, you draw a graph that's concave up. Just a simple graph that's concave up. Doesn't have to be a particular graph. Concave up. And now we'll draw a tangent. Okay, and if you draw a tangent to a graph that's concave up, any tangent that you draw to a graph that's concave up is always going to be below the graph itself. Okay, so the tangent to a graph that's concave up is always below. Tangents are always below graphs that are concave up. And so that means the answer in part A was an underestimate. Okay, the graph in part A was an underestimate. Hopefully that makes sense. So you basically look at the second derivative to determine whether the second derivative is positive or negative. If the second derivative is positive, then the graph was concave up, and tangents are always below graphs that are concave up. And if the second derivative had been negative, then the graph would be concave down. And if you drew a concave down graph, you would find that the tangents are always above it. And so in that case, it would be an overestimate. But in the one we have here, it's an underestimate. Okay, hope that helps.